Hello everybody, hope you guys are enjoying your day. Today we're going to be looking at your first winter discussion of the year 2020, and this is going to be going for the winter of 2022-2021. Now we're going to be going over my winter forecast. I already uploaded my winter forecast, but what we're going to be doing today is actually looking at why I made my winter forecast the way I did, and just the scientific reasoning behind why. Now this is going to be a bit of a longer video, probably around 20 minutes, so you can fast forward if there's something that you really want to know about. So you can always fast forward there, or you could just watch the whole thing. We're going to be going a little bit more scientific and in depth in today's video than what I usually do. Now this is because that's just mainly because in my regular videos I really don't want to go too detailed, just in case I confuse anybody or I kind of get a little bit boring. So I don't like to go too in depth in my regular videos, and also my winter forecast I really don't do that too much. But in this winter discussion, I am going to be going more in depth than I would typically go. We're going to be going over some analog years, or years that look similar to this year. We're going to look at some of your long range forecasting, and also your La Nina, your El Nino, or your neutral, and we're going to see whether which one we are going to have and what that could play, or how that could play into this winter. Now, if you did not already, go check out my first preliminary winter forecast. It's up on my channel, and I go over my personal forecast. So that's probably something that you have to watch if you want to watch this video, just mainly because I'm not going to show my forecasts in this video. I'm going to just be talking about referencing my forecasts that were in this video. So you kind of have to watch this video if you want to really get, if you really want to know the context for this video that I'm making right now. So here is, let's start off with some of your analogs. So these are some of your years that look similar to this year, and this is years that have weak La Ninas. And here are your temperatures, or I believe this is actually these are your temperature anomalies for those years. And then anywhere in these greens and those blues, that's below average. Anywhere in the yellows, that's above average, and anywhere in the white, that's pretty much average. So what you can really tell from this is that this is in a typical weak La Nina, and in all the years that you can see, if you are really interested, are right up here. So these are all the analog years. This is going from December to February, and then we're going to go into each individual month. But you see, for much of the northern plains and the western United States, we are going to see, according to these analog years, and again, these are just past years, and I averaged them out and I made a composite, which is basically taking all those years, putting them on one map, and this is the average of what they showed. And you see, we have most of these areas between 1 to about 3 degrees below average, and some areas in Montana and the Dakotas seeing even up to 4 degrees below average, or even colder. And for the southeast and the middle Atlantic coastal areas, you could see probably about, this is only about half a degree to a degree above average, so nothing that's going to be too significant. And you can always have some patterns that last for about a week, a couple of weeks, that could actually flip this around, where you could actually have colder for the eastern United States, warmer for the west, or vice versa. So this is just on average for those entire winters from the time period between December to February. So let's go to your precipitation, and then we'll go to every single individual month. And here we have anywhere in those yellows, oranges, and reds, below average precipitation. Anywhere in those greens and blues, that's where we have above average precipitation. And we see over parts of the northwest, we have some above average precipitation as well. For parts of the eastern United States, we have some above average precipitation. For the southern tier of the United States, and also kind of right along the immediate west coast, we're looking at some slightly to even moderately below average conditions, and that was in my forecast, and I'm feeling pretty good about my precipitation forecast so far. Temperatures and the snowfall is really where we have a little bit of more issues in terms of whether it's going to be more closer to an average year, or if it's going to be maybe even below average, or maybe we could have even a above average year. So that's something that we really have to pay attention to, and that's something that I'm trying to figure out currently, and I'll update my winter forecast and this winter discussion as we go along with time. So here is your December for all those same analog years, and you see December was fairly cold for most of these areas. And even though these areas that are in white, that are still close to these below average region, even though they're still in white, that means that they're still between about 0 degrees and 1 degree below average. So some of these areas, even if you are in white, you still could be below average or above average, although it would be very marginal. But you see, for much of the and especially the central United States, and then stretching into the northeast, we did have some below average conditions, and then just a little pocket here for the southeast, which was in my forecast. We have a little area of above average conditions. So here is for January, and you see pretty much the same story, except much colder for the western United States, and it stays cold for much of the northern tier of the United States. And you see all for the west and then through the Great Lakes and into parts of the northeast, below average in terms of your temperatures. Now, here is for February, and you see February gets very, very warm, and all of these analog years have a very, very warm February. So you're going to have to pack in your snowfall between December and January, maybe some early snowfall into parts of October and November, and then also some late snowfall if we, and I'm going to show this, March, April look very, very cold. So really you only have one really warm month, which would be, especially it's only for the eastern United States, central United States still very cold, but only for the eastern United States you have some above average conditions, and that goes away by the time you start to get into March, but still extremely cold over parts of the north central United States, and this would be by February, and then here's March, and it starts to turn colder again for pretty much the northern two-thirds of the country. By March, it is very, very cold, and then here's April, and you start to see heat builds over the south and south central United States, but for anywhere north of there and west of there, you are still seeing some colder than normal temperatures, and we could potentially have something like what we saw this year in terms of the spring, where we had snowfall into parts of the Great Lakes and the Northeast and North Central United States into May. So you could have some lingering snowfall all the way through April and May, and some mountain snowfall that could linger all the way into July or August. So definitely a very, very cold pattern that looks to set up for this winter, especially if you live in the northern half of the United States, I would say. So here is your here is for some of your moderate La Nina years. Now, moderate La Nina just means that it is colder over the equatorial Pacific, and we're going to go a little bit more into depth on that in a little bit. But this is for years that would include 1955 to 1956, 1970 to 71, 1995 to 96, and 2011 to 12. So these are some of your moderate La Nina years. We don't have too many years to go off of, so this is a very average. This map is very, very close to average in terms of your. This is your precipitation anomaly, so this is very, very close to average. Only area where you have significant above average precipitation is for parts of the northwestern United States, and you see a little bit of below average over parts of the southeastern United States. Other than that, it is very, very close to average, within an inch or two of average. Now, here's your temperatures, and you see in a moderate La Nina, it is a little bit warmer. That warm air starts to move a little bit further to the north, but still, for the northern, I would say one-third of the United States, you still have some fairly decent cold air on average for December to February. Now let's go through every individual month here. So this is December, very cold for the northern plains and the northeast there. Here is January, and you see the north central and also parts of the Ohio Valley and northeast still colder than normal. Here is for February, and you see it kind of flips, and again, this is what you saw with the weaker La Ninas, which is the maps that I just showed. You had also warmer than normal temperatures all throughout the eastern United States for February, but for the western United States, you're actually seeing those colder than normal temperatures. And then as we start to look into March, you start to see it gets colder again, except for parts of the central part of the country. You're a little bit above average, and then as we get into April, well below average again. So what it's looking like is that December and January you're going to have colder than normal conditions, as well, most likely above average precipitation and snowfall. And then for February, you're going to have a really warm stretch, probably throughout the heart of February. And then as you start to get to March and April and May, it's going to cool down significantly, and you could also see some late season snowfall again. So looks like a fairly decent pattern. The only thing that really will upset your snowfall, really, especially for the eastern United States, the eastern third, is going to be that February, where most of these areas actually have your snowiest month in February. February. So that'll be something that you have to kind of battle. But if you can get a snowy enough January and December, as well as snowy March and April, where you can actually get a couple of nor'easters probably in March and April, you could definitely pretty much go away with February, even if you don't see any snowfall in that month, and then you could still be above average, even if you see a very, very warm February. So definitely don't be too upset if you like snow and cold, and you live in the eastern United States for February. I think it definitely won't play too big of a role into this winter. Now, let's look at some of these your total snowfall accumulations for some years that were in a weak or moderate La Nina, or even one of these years is actually in a strong La Nina, just to show you what kind of effects this can have on your total snowfall. So this is from NOAA, and this is from all the observed snowfall readings, and they actually just put them all into one map for the entire season. So this is for the winter of 2008 to 2009, a weak La Nina here, and we did see a fairly average season for many, a little bit above average, especially as you get into that northern one-third of the United States, but generally fairly average. And for the south central United States, you actually did see a fair amount of snowfall. So even though those areas were warmer than normal, maybe you could see some snowfall. That is, those areas, especially for the south, it is very hard to forecast for those, because it is very, very specific scenarios that really can't be forecast too far out that will lead to snowfall in those areas. You need a very, very cold atmosphere. You need a system to ride through that area. So it is hard to get snowfall throughout that area, and it's also hard to forecast it. But that is something that in these La Nina years, it does look a little bit more likely to happen. Now, here is from 2010 to 2011, and you see this was well above average as a whole, especially for the northeastern United States for 2010 to 2011. This is a strong La Nina, so that is something that we aren't really expecting too strong of a La Nina, maybe a moderate at most. So that is something that we'll have to see. But if we do see a strong La Nina, that could definitely be very, very good for you snow and cold lovers, especially if you live in the Northeast or the Great Lakes, where you saw a very, very large amount of snowfall that year, about a 2 to 3 feet above your normal. So here is 2011, 2012. Well below average year actually, and that was a moderate La Nina. So definitely something interesting to see. We only have one of these years. This only goes back to 2008 and 2009 when they started this, so we don't really have too many. There's only three other moderate La Ninas: 95, 96, 70, 71, and 55, 56, where you had moderate La Ninas. So we don't have too much data on those. So even though you see this and you're seeing, oh, I don't really want a moderate La Nina, there's not too much snowfall in those winters, that could definitely be very misleading. We only have one moderate La Nina as instead of the three or four that we have for weak La Ninas, and we have another one for strong La Ninas. So this can be very misleading, and usually moderate La Ninas tend to be closer to average, if not a little bit above average, for the northern third of the United States. And here is your 2016 to 2017 season, a weak La Nina, and you saw a fairly average to maybe even above average season, especially for the northern quarter or fifth of the United States, for parts of the northern Great Lakes and the northern New England regions. You saw above average snowfall in those regions. Other than that, a fairly average season, and that was a weak La Nina. And then here's your 2017-2018 season. There's a little bit of a snow drought for parts of the Ohio Valley, Tennessee valleys, but for the Northeast and also for the Upper Plains, you did see above average snowfall, and this was a fairly above average snowfall season, and this also fell into the category of weak La Nina. So let's start talking about what a La Nina actually is, because you've been hearing me use that term quite a bit, and you might not even know what it means. So let's go over it a little bit. So here's where the La Nina region is, and it's generally within this region where we're looking for those cooler than normal temperatures, or any type of anomaly in those sea surface temperatures. These are your sea surface temperatures for the entire world, and we're just going to focus in on this little region here off the coast of northern South America. So we have some cooler than than normal temperatures right now, and that indicates a La Nina. If we had closer to normal temperatures, that would indicate a neutral, like we saw last year. And if we had some of those warmer than normal temperatures, we would have a El Nino in place, and that's definitely not what we're going to see this year. A neutral still on the table, but not looking too likely. La Nina very, very likely to see this year. We have a decent La Nina forming, a weak to moderate La Nina currently in place. Something that's really throwing it off is that you can see here over parts of the western region of this Nino region, we have some warmer than normal sea surface temperatures starting to intrude there. So that is something that we have to pay attention to. That could swing our La Nina a little bit further to a neutral. But if that does go away, then I think we have a decent shot of seeing a moderate to maybe even a high-end La Nina on our hands. So here is your Nino 3.4 index, and that's over that entire region pretty much. And you see currently it's a little bit, it's very, very close to average. Here's currently where it is, and you see it's very, very close to average. It was a fairly strong La Nina. This was a weak La Nina by this point, and now it's starting to head a little bit warmer, and I think it is going to dip back down to a weak La Nina, if not a moderate La Nina. We still have a lot of time for this to develop and to strengthen into a El Nino, or to kind of get a lot colder into a La Nina. Now, here's another region, the Nino 1.2 index, and if we actually go back a little bit, here's the Nino 1.2 area, and you see this is the region where it's just way below average, and that's why if you look at the Nino 1.2 or 1+2 index, you see it's well below average, -2 degrees. That would be a moderate to a strong La Nina right there. So here is your Nino 3 index, and this one is also cooler. That was kind of in the middle of that box I drew before. And you see we have a weak to even a moderate La Nina. We used to have a little bit of a moderate La Nina right around here, but that did go away after a little bit. And here is from NOAA. This is the official NOAA graphic for what a typical La Nina looks like. And you do see this is a typical La Nina, and every La Nina is different, so definitely take this with a grain of salt. And we have colder than normal conditions for parts of western Canada as well as the northern plains. That is definitely a given for this winter. Wetter than normal conditions for the northwest. That's definitely something that is likely. Drier and warmer for the southeast and south central. Definitely something that looks very likely. And here's your jet stream, by the way. This big blue arrow, and this is definitely something that's going to fluctuate throughout the winter. It's going to change multiple times throughout the winter. So something that is more of a short-term type of thing, but this is the general storm track, and you see usually the Ohio Valley actually sees quite a bit of snowfall, but especially as you get into March and April, that's when this starts to track further east, and that's when the Northeast starts to really get hammered with quite a bit of nor'easters and snowfall, especially in these La Nina years. Now, here's a little kind of a cool graphic I found. This is from NOAA, and this is a composite anomaly, and this is basically taking all of your La Nina years, anywhere from a weak to strong La Nina, and this was made by NOAA, and they put this together and they showed what the snowfall departures were from normal. So it's a bit hard to see. It's a little bit, it's very, not very high resolution, but there's nothing really I can do about that. So here on the left-hand side here, this is your anomaly, and on the bottom of your screen right here, you can see this is the departure in inches to how much snowfall you typically will see. For the western United States, well above average, especially in those higher elevation regions. A little bit of a drier area for the central United States. You also see a little bit of that pocket for parts of Pennsylvania, New Jersey, Maryland, Virginia, and parts of the coastal mid-Atlantic. That is something that happens. If you look on the right here, this is your frequency. That happens between 60 and 70% of the time. But I think this is probably going to be one of those times where it's not going to be in that 60% to 70%. I think it's probably going to be in that 30% chance, where usually in 30% of these La Nina winters, you will see above average snowfall. I think that's going to definitely be the case this year. And if you actually look at these anomalies for those regions, for much of these regions, it's only by about 1 to 3 inches, which is really not too much. And then you go a little bit further north into northern New England and the northern Great Lakes, and you're back to 5 to about 10 inches above your normal in inches, and even a little bit more for some of those higher elevation regions. So that's a little cool map that I want to show you in terms of your snowfall anomalies. Now let's start looking at your modeled forecast, and I'm sorry this is a little bit of a longer video. That's just because there is a lot to cover, and I really want to squeeze it in, and there's no real way for me to squeeze it in into a shorter time period. So I was debating on whether to do this as a live stream, but I decided why not just do it as a video. It'll be a longer video, so this will definitely give you something to watch over the next couple of days. So here is your modeled guidance. Now we're going to just look at the CFS model and what it's showing. Keep in mind the CFS model is notoriously a warm based model, so it's a warm bias model. So when you start to see those cooler than normal temperatures, that is something that you want to pay attention to. So here is December, and these are your height anomalies, by the way. So this is basically, I like to use this more than your temperature anomalies, just because they kind of fluctuate a lot more than these height anomalies. Now you see anywhere in these reds, that's usually where you see above average temperatures. The above average temperatures. In the blues, that's usually where you see below average temperatures. Now this can be a little bit misleading, especially if you have a high pressure system. That will indicate a orange shade, but that doesn't mean that it actually is warmer. A high pressure system coming out of Canada can actually bring cooler than normal temperatures. So it's something that's a little bit misleading. But you see, for December, it looks cooler for the western and southern United States, and for the northern and central United States, it looks warmer. But then things start to change. Here's for January, much colder, and this would be indicative of a negative NAO pattern, which we'll go over in just a little bit, and then we'll wrap up the video. You see, we have much cooler than normal temperatures for parts of the northeastern and north central United States, as well as the southwestern United States. Here is February, and you see we have much of the eastern two-thirds of the United States under colder than normal temperatures. Here is for the entire time frame between December, January, and February, just averaged out, and it is on average cooler than normal. So here's your precipitation, and this is something that really intrigued me when I looked at this, because this isn't typical of a La Nina setup, but some La Ninas do serve this up, because every La Nina, remember, every La Nina is different, and every La Nina can switch what they give for that winter. So what we see forecasted for this winter. This is by December. It has above average precip for parts of the eastern seaboard, and then back through the Tennessee Valley as well, a little bit there for the central and western United States, and a drought for the northwestern United States. Now, what this would show is mainly systems kind of riding in between this area and then kind of moving up the east coast, which would be a good sign for snowfall along this area right here. That's where you would see most of your snowfall. And even if you have average precipitation, still you're probably going to see more snowfall than average, especially if you're in a colder than normal area. Now, here is your January forecast, and it is pretty much the same, and this actually would show most likely some sort of nor'easter setup where you actually have a high pressure system blocking it further to the north and to the east, and it would stall out over this area, just dumping snowfall or rainfall depending on the exact situation. Now here's for February, and you see this is when you really would start to see your nor'easters develop, when it's really tracking in between that drier and warmer than normal or drier and more precipitation area, and that's something that just really caught my attention and really caught my eye. Now here's a look at this is the same CFS run, and this is just showing you over the northern hemisphere what it's looking like in terms of your height anomalies. Now, what you like to see is for especially cold, you really want that negative NAO. And what is an NAO? That is a type of oscillation, the North Atlantic Oscillation, and that is especially the area for that is over this area mainly. This is mainly the North Atlantic Oscillation region, and you see over that region we have negative departures from normal. So we have a cooler than normal height anomalies. So what that would indicate is a negative NAO, and you might actually have heard that before. And what that means is usually you have cooler than normal temperatures for the northern Atlantic. You have low pressure systems throughout that region that usually will indicate blocking over Greenland and over parts of the Arctic, and that's also an Arctic oscillation. And when you have a positive AO and a negative NAO, that usually spells very cold temperatures and very snowy conditions for parts of the eastern United States and even the central United States in most scenarios. So here's a look at that North Atlantic oscillation and what it shows. Now, here is it when it's in positive mode. You see warmer than normal conditions for parts of the eastern United States. You have cooler than normal temperatures just for that northern region, so right north of that jet stream. But when you get that weak low pressure system to form in parts of the NAO region, that's when you can really start to see that you start to see ridging out throughout the northern Atlantic. And what that means is that it has to go down sometime. So what you end up seeing is you have a dip in the jet stream over the eastern United States, and then a big ridge over the North Atlantic, and then back through northern and central Europe. You start to see even colder than normal conditions, and that means colder and snowier conditions. Remember, that's your jet stream, and that means that your systems are going to ride throughout that region, and that's usually when you see a lot of your snowfall for the eastern, especially the northeastern United States, as well as the Great Lakes. So something that's very, very interesting, especially we have a lot of different things coming together, and it looks like it's going to be a fairly good winter in terms of snowfall, your colder than normal temperatures, and I'm really excited for this winter. I'm going to be tracking all of those snowstorms, especially as they start to move into parts of the eastern United States. I'll also track some of those very cold air masses that dip down, so definitely make sure you are subscribed. Go check out again my my preliminary winter forecast. That's where I have all of my official forecasts. This was just kind of a discussion, so definitely go check that out, and that is gonna wrap it up for today's video. I'll see you guys in the next video, and goodbye.